Hello, my name is Brandon Huff, and this is my presentation on blockchain. Blockchain consists of blocks, which is a continuously growing list of records. These blocks are secured using cryptography. Each one of these blocks will typically contain a cryptographic hash of the previous block as well as a timestamp, and transaction data. By design, a blockchain is inherently resistant to modification of data. A blockchain is typically managed by a peer-to-peer network that will be collectively adhere to a protocol for internode communication and validating new blocks. The data in a given block will not be able to be altered without altering subsequent blocks, but that will require collision of the network majority. This technique of blockchain was originally described in 1991 by a group of researchers that intended to timestamp digital documents so that it was not possible to backdate them or to tamper with them. When the white paper Bitcoin, a peer-to-peer electronic cash system, was published by Satoshi Nakamoto, was released in 2008 is when blockchain was made public and started to be used. In 2009, Bitcoin became open source to the community. This peer-to-peer version of electronic cash was and is still known as Bitcoin. Blockchain is used to Bitcoin what the internet is to email. According to Sally Davis, this technology of Bitcoin is a big electronic system on which applications can be built. Currency just happens to be one of them. With supply chain management, the blockchain technology will offer the benefits of traceability and cost effectiveness. Blockchain is able to track the movement of goods, their origin, and quantity. This allows simplification processes such as ownership transfer, production process assurance, and payments. With quality assurance, if an irregularity is detected along the supply chain, a blockchain system can tell you the point of origin that broke the integrity. With accounting, blockchain can virtually eliminate human error and protect data from possible tampering. This is able to be done because every record added to the blockchain is verified every single time they are passed one from blockchain node to the next. This will also leave a very traceable audit trail. This also allows for businesses to keep a single joint register, which is more efficient on a foundational level. With smart contracts, agreements can be automatically validated, signed, and then enforced through a blockchain construct, versus the very time-consuming transactions that can bottleneck the growth of a business, especially for huge businesses or enterprises that process a torrent of communications on a consistent basis. Each block contains some data, the hash of the block, and the hash of the previous block. The data that is stored inside a block depends on the type of blockchain that is being used. The hash in the blockchain identifies a block and all of its contents and will always be unique. When the block is first created, the hash will be calculated. If any data inside the block is changed, then the hash of that data will be changed. This is very helpful to check if any changes have been made to any blocks. For example, each block has a hash and a hash to the previous block, like I said above. BC2 contains the previous hash that will point to BC1, as well as BC3 contains the previous hash that will point to BC2, as shown in the diagram. If BC2 data was changed, then the hash of that block will be changed, in turn making all the following blocks after B2 invalid. But with modern computers, rehashing for each block can be done very fast in order to get a valid blockchain once again. In order to prevent this, blockchains have what is called proof of work, which slows down the creation of new blocks. Blockchains also use P2P networks. What this means is that everyone on the network will have a copy of that blockchain. When a new block is created, that block is sent to everyone on the network. Then each node will verify that the block made if it has been tampered with or not. If the block is verified and has not been tampered with, then each person adds this block to their own blockchain. All the nodes in this network create a consensus, which means that each person in the network will agree with which blocks are valid and which are not. Any blocks that are tampered with will be rejected by other nodes in the network. In order to actually be successful in tampering with a blockchain, you must tamper with all the blocks on that chain. Redo the proof of work for each block, which could take 10 minutes or so, and take control of more than 50% of the peer-to-peer network. But this is quite honestly almost impossible to do. When it comes to autonomous vehicles, all the companies will be on the DAV network, and this is open source and is available on GitHub. This source code is written so that it can be implemented into any autonomous vehicle platform. This DAV network uses blockchain in order to work. The team of advisors for DAV come from the top-tier organizations such as Ethereum, Google, and even NASA. With Internet of Things, systems connect to a variety of physical objects such as mobile devices, sensors, and actuators to the Internet. This device will either sense, communicate, and exchange information with each other to achieve a certain goal in mind. Although some of these Internet of Things devices are low-powered, geographically distributed, and possibly mobile, they are limited in their computing resources and energy supply, which is a major barrier when blockchain is implemented into these systems. Thank you for watching my presentation on blockchain. Here are all the references that I used to make this presentation.